Fundamental theorem of algebra. Find the third-degree polynomial function f of x with real coefficient that has minus 3 and I as a zeros, and such that f of 1 is equal to 8. According to fundamental theorem of algebra, we already know if a polynomial function is of third degree, it means has 3 solutions in the complex field. Because here we have a minus 3, this is one real solution, and the other is I, imaginary complex solution. But imaginary complex solution always comes as a conjugate solution. It means has 2 plus or minus I, plus and the minus I. If it is here as plus I one solution, the other has to be with this conjugate, with the same in the quantity, but with a different sign, minus I. So now, according to the linearized factor theorem, if a polynomial function is an n degree, it means it has an n solution. What does it mean? It means it has an n linear factors. So now, this polynomial function in third degree, we can write in the linear factors. And we can write in this way. Let me take one pen. So f of x is equal with the an, so this is a general formula, an, but because we have a solution here, minus 3, so the factor is going to be with the opposite sign. What is here, minus 3, is going to be x plus 3. And now I'm going to look for the second one, is I, but instead here is a positive, so the factor is going to be x plus I, minus I, with opposite sign. And the other factor, I know the other solution is going to be minus I, the other solution. So the factor is going to be with opposite sign, it means x plus I. And now I'm going to simplify, so I'm going to multiply those factors between each other, so the polynomial is going to be the simplified form. And first of all, let me multiply the last two factors. The first one I'm writing in the form how it is. This is leading coefficient an. So this an we have to find it because we don't know yet what it is. And the first factor I'm writing in the way how it is. But the two factors here I'm going to multiply. X times x is equal to the x squared. So this is x squared. X times plus I is plus ix. So this is I plus x. And now I'm going with minus I times x is minus ix. Minus ix. And minus I times plus I is minus I squared. So, but I squared is a minus 1. We already know as a complex number. This is a minus 1. I squared. And negative times negative is going to be positive plus 1. But first of all, let's write here this function a little bit in the more simple form. And like terms, let's add or subtract, let's work with them. So an is here. And now I have x plus 3. Let me write and one extra term. X plus 3 here. And now what do I have here? This ix minus ix simplifies, and let me write here x squared, the first term, and this is I squared is a minus 1. Negative times negative is positive, it means it's a plus 1. So this is what we have here. And now we are multiplying everything in this, what we have inside. F of x is equal to the an. So an is here. And if we multiply everything, x times x squared is x cubic. So this can be x cubic. And x times 1 is plus x. Is plus x. And plus 3 times x squared is a plus 3x squared. Okay. And 3 times 1 is a plus 3. What do we have now to do? So now we take in this condition. F of 1 is equal to 8. So I want to find the an. To find the an, we have to apply this condition. Whatever is x, I am going to plug 1. The value is 1. But for the y is value of, or f of x, the value is 8. So let me write a different color here and let me find. This is 8 is equal an. Let me write an, this function here. Instead of x cubic, I'm writing 1 cubic, okay? Plus, instead of x, I'm writing 1. And here is a plus 3 times x squared, which is 1 squared. And here is plus 3. And let me reduce this problem a little bit more. And this is going to be 8 is equal with the an. And I'm going to add everything inside parentheses here. 1 cubic is 1 plus 1 is 2. 3 times 1 squared is 3 plus 3. 3 plus 3 is 6 plus 1 7 plus 1 is 8. And if I divide everything here by 8, if I divide here everything by 8, so finally I can find a in a n is equal with 1. So this is an. And now instead of an, here f of x I can plug in. Here is a 1. Here is a 1 time. Just let me write this function a little bit more in the standard form, from the highest degree to the smallest one. I can write 3x squared. Then I can write plus x plus 3. Plus x plus 3. And if I multiply everything by 1, so the function is going to be the same. So f of x is equal. So we have this function. We already got the function is x cubic plus 3x squared plus 3x squared plus x plus 3. So this is the final answer.